Hello, welcome to this session on inverse trig functions. So we're just going to do a few questions and we're going to introduce it with a non-calculator question on evaluating cosec of arc cos root 2 over 2. Well, you wouldn't have to do this in the exam because you've got a calculator, but here we're just a bit of an exercise really. So what we understand is we'll soon see what this is anyway if you don't already remember. Well, inverse cos of root 2 over 2. Cos is adjacent over the hypotenuse. There's a little triangle. I've got the angle coloured in blue there. So this one here, that side, and this will tell us everything, that side would be the square root of 4, which is 2 squared, minus root 2 squared, which is 2, i.e. square root of 2. And there we've got an isosceles triangle. So that is clearly 45 degrees, or we're dealing in rads here. So it's pi over 4. You could always get these in an exam, but it's a good idea to understand where these are from. So we then need, cosec of pi over 4. Well, that is, of course, 1 over sine of pi over 4. Well, sine of pi over 4, sine of 45 degrees. Well, from the same diagram, I can see that is actually root 2 over 2. So 1 over root 2 over 2 is 2 over root 2. We don't really like having the surd at the bottom. So I multiply top and bottom by root 2. And you'd have 2 root 2 for root 2 root 2. And that, of course, gives you 2 root 2 over 2, which quite nicely gives you root 2. So there we are. There's your final answer. That is root 2. And it just really is a little exercise in understanding that you're dealing with an inverse trig function and then you're dealing with a reciprocal trig functions and understanding the surds. Hello, here's an exam style question on inverse trig functions. We're looking at a situation here where x satisfies arc cos x equals k. And we're defining k as being between 0 and pi over 2. So we're going to state the possible range of values for x. So let's just have a little think. So what is arc cos? Well, arc cos really is an angle. It's the angle, and let's call it alpha for now, in the range between 0 and pi. So arc cos, inverse cos, exists between 0 and pi. But we're saying such that cos alpha equals x. So x is really cos of alpha here, cos of something. Now, So we've got the situation then that x equals cos of k, but we know k is between, or it's greater than 0 and less than pi over 2. So, well, what happens here? We think about what happens in the cos function between 0 and pi over 2. Well, it starts at 1 and goes down to 0. That's between 0 degrees and 90 degrees if you're working. Little cos graph. It's just that bit, that first bit, that cos graph. So x has got to be less than 1 and it's greater than 0. So that's for part A. So arc cos is a function, an inverse trig function existing between 0 and pi. And here we're thinking, well, if we're talking about the angle alpha, cos alpha equals x. But here we've got x equals cos k. And we're saying k, the angle k is between 0 and pi over 2. So it's got to be between 0 and 1. Well, let's look at B. So sine of k, well, what does sine of k equal? Sine of k has got to be the positive negative square root of 1 minus cos squared k. Well, that equals the positive negative square root of 1 minus x squared, because cos k equals x. Cos k equals x. Arc cos x is k, so cos k is x. Now, really, since we're dealing with the first quadrant, since k is between 0 and pi over 2, we know that sine must be positive in the first quadrant. We think about our cast diagram. Just draw that there. We're here where everything is positive. The final answer would be sine k equals positive square root of 1 minus x squared. Part 2, we know that tan k is going to be sine k over cos k. So sine k was done before. The last question is 1 minus x squared. And square root of, and cos k is x. So there we go. Hopefully that makes some sense. Do pause and reflect on what's been done here. Now, if I change this, I'll just explain, see. We've now got a different range of values. We're going into the second quadrant. So we're going into where just sine is positive, everything else is negative. What would happen with part C? What would happen with part B, your answers to part B? Well, in this case, actually, sine would still be positive. So that wouldn't change. B would stay B part 1 would stay the same. But in part 2, where you've got sine over cos, only sine is positive. Cos is negative in the second quadrant, so we'd actually have a negative answer in part 2. Now, I hope that makes sense. There's a similar question to that in the Pearson textbook, so do have a go at that. Okay, I hope you understand so far. Let's finish off with a little graph sketch question. Well, as ever, I'm cheating by using Desmos to sketch it for me, which is a bit naughty, but makes it clearer. So we're going to sketch y equals pi plus arc cos of 2x. Well, there's your arc cos graph I've just put on there. Goes between -1 and 1 on the x-axis, and the y values range from 0 up to pi, as you can see. When I add pi to that, you can see it just shifts up. It's a translation. 0 pi parallel to the y-axis. So if I get rid of my original one there, you can see that's pi plus arc cos x. Well, what we're sketching pi plus arc cos 2x. So we're changing the input. So it's going to be a stretch. Remember, it's going to be a stretch parallel to the x-axis, scale factor 1/2. So this graph is going to squash. There you go. There's your new graph. Let's just go through that again. There's your arc cos graph, which you'll recognise, and that's something you need to learn, and that needs to be second nature. I add pi to that. It's a nice simple translation. There you go. Well, what do I do now? I just need to squash it. I need to do a stretch scale factor 1/2 parallel to the x-axis and watch this squash. There you go. Now, thanks to Desmos. And if you are struggling with your sketches, get yourselves on Desmos. It's very helpful. It's just great fun. Okay, thank you very much.